3.4. What? They already got put in. Yeah, guys, the all or nothing quizzes got put in.
No, one side is the butt. And on the other side, it's just
Okay, so last year you guys definitely talked about concavity, right? How did you guys determine if things were concave up or concave down?
With the rate of change of the rate of change.
Yeah, the rate of change of the rate of change, right? Kind of a pain, do we agree? But what do we know? So rate of change is which derivative? What would the rate of change of the rate of change be? Second derivative, right? So the stuff from pre-calc feeds into this, right, where we have a more formalized way of doing it. Okay, so we're going to say f is differentiable on an open interval, okay? What we can say is the graph of f is concave up. It's really concave upward, but we'll just say concave up on I, so on that interval, okay? I should have included that, on interval I. Okay, on I when the first derivative is increasing. On the interval. What do you guys think about concave downward then? When it's decreasing. So tomorrow I would expect for us to do notes on a summary of curve sketching, and then I would expect us not to have more homework. Right? So right now you guys are sitting at 4 book assignments for this week. I will say the first 2 should have been pretty quick. Even yesterday's is like, these book assignments should not be taking hours upon hours. They're relatively quick. Am I wrong? I'm wrong? No, they are relatively short, right? Okay, the idea is when I'm gone Monday is I really want us to practice this summary of curve sketching. Does that make sense? Okay. Are we all good here? Do I need to draw a picture of kind of what this looks like? Would that be helpful? Okay. Here's the idea. Do we agree that this graph right here, do we all agree that this is concave up? Okay. This tangent line, right? If I drew a tangent line, that's clearly negative. Do we agree? Okay. What about if I drew a tangent line here? Okay, is 0 bigger or smaller? Is 0 bigger or smaller than a negative slope? Okay. What about if I picked here, right here? So, do you guys see how if this is the graph of f, my first derivative is increasing on the interval? Does that make sense? That's all that this is saying. Okay. Are we still writing this? Yeah? Okay. Take a minute. Also, so your guys' all or nothings got put in?
Yeah.
You either got all of the points or none of the points. Also, I'm going to be real. The way that I graded, as soon as I saw a mistake, it just was a 0. So if you guys are like, hey, which ones did I miss? I don't know. I saw the first one, and then that was it. What? No, I didn't look at the names. I actually actively try to avoid looking at names when I grade tests. Because like I'll have biases where like I'll be like, oh well, I've known this person since they were a freshman and I've known where they've started, and I tend to give more points than what you guys deserve. Or if it's people like Brandon who I just dislike, no points. Don't make me put the caterpillar back up there. You know what? I'm gonna actually make a poster of it, and that's gonna be my social contracts. For the first time in 7 years here, guys, I'm gonna make a social contract. Remind me at the end of this, so that way we can all get behind it, and then I'll make a poster of it, and we'll all sign it.
What is our social contract?
It's gonna be a picture of Brandon Mosley as a caterpillar. I'm not doing. Oh, it is Lorelai's birthday. Thanks for the reminder. We'll go down there at the end of this. Okay. Okay. So we are going to have our test for concavity. This is not to be confused with the second derivative test. Okay. So this is test for concavity. All right. So what we're going to say is f is a function whose second derivative exists on this interval I. I'm not going to write all of that, but we're all good. Second derivative exists, okay, on this open interval. The first thing that we can say is if f double prime of x is greater than 0, okay, for all x in this interval, then f is concave up. If f double prime of x is less than 0, then, okay, f is going to be what? Concave down. So, what am I missing? If the second derivative is 0, what does it mean?
No content. So minus point of inflection or whatever.
It's linear?
It's linear, which means it's not, concavity is not defined for a line. Does that make sense? So if it's 0, it doesn't tell us anything. Does that make sense? Okay. So today's notes are going to have a very similar flavor where we're making these tables. We all good to move on to an example? Okay. Determine the open intervals on which this function f of x equals e to the negative x squared over 2, right? Determine on which intervals it's concave up and concave down. So, what do you guys think that we're going to have to do? Well, we got to find the first derivative and then the second derivative, correct? Okay. Our first derivative. Yep. So hopefully we're getting to the point where I don't have to write this out a whole bunch. Negative x e to the negative x squared over 2. Nope, that's it.
Wait, you don't do.
That is the chain rule. Because the derivative of e to the u is e to the u times u prime. What is the derivative of negative x squared over 2? Negative 2x over 2, which is just negative x. Okay, now what do we need to do? Take the second derivative. What rule do we need to use? Product and chain rule. Do we agree? Okay, what is the derivative of negative x? So we get negative e to the negative x squared over 2 plus negative x times, what is the derivative of e to the negative x squared over 2? Negative x times e to the negative x squared over 2. Do we agree with that? What's that? Okay. All right. We have the second derivative. There's a better, more advantageous way to write this because I'm thinking ahead. Because what do we now need to do? Set it equal to 0, right? So knowing that I'm going to set this equal to 0, it would be hard to find whatever our roots or whatever were, right? You guys with me? Okay, so first things first, right? I can multiply negative x times negative x. What do we get? Yes, we have negative e to the negative x squared over 2 plus x squared e to the negative x squared over 2. Is there anything that we could factor out? The negative, right, or the e to the negative x squared over 2, right? So I'm going to go ahead, I'm going to set this equal to 0 now, and I'm going to factor out, right, your e to the negative x squared over 2. That's going to be x squared minus 1. I'm flipping the order, right? If I factor out this e to the negative x squared, I get negative 1 plus x squared, which is x squared minus 1. Okay, what values? What are our values? What does x equal? 1, negative 1. Does e to the negative x squared over 2 ever equal 0?
No.
Okay. We're good there. So here's our two values. Good? Those are, well, these is when the second derivative is equal to 0. So critical values is when the first derivative is equal to 0. Okay. All right, so what are our intervals going to be? Negative infinity to negative 1. Then what? Negative 1 to positive 1. Then what? 1 to infinity, right?
Yep.
Okay. So to be clear, I don't want you guys to forget everything that we were talking about yesterday, because when we do summary of curve sketching, we're doing first derivative test, increasing, decreasing, maximums, minimums, concavity, right? Points of inflection, which we're going to build up to. So it's all of these things. So just because today's table's short, what we're doing tomorrow is smushing them all together. Does that make sense? Okay. So what, after we say what our interval is, right? This is our interval. Okay, what do we then pick? We pick test values. Okay, what do you guys want to plug in our first interval? Negative 2, 0, positive 2. Okay, what are we trying to determine? Concavity. So do I care anything about the first derivative right now? No, I only care about the sign, right, of f double prime. Okay, so we plug f double prime of negative 2. What is that number going to be? It is going to be positive. Do I care what that value is? No. Do not. Okay, it being positive tells me what? That it's concave up. All right, when we plug in f double prime of 0, what do we get? A negative. So that is less than 0, right? So positive, negative. If it's negative, what can we say? There we go. All right, f double prime of 2. What's that going to be? Positive. Okay, which means it is. Okay, so on which intervals is that function concave up? Negative infinity to 1. Union 1 to positive infinity. On what interval is it concave down? Negative 1 to positive 1. Does that make sense? You guys are gonna do one on your own now. I'll give you guys a couple minutes. How are we doing, Gabe?
So the actual, so no matter what value, so no matter what you do with the exponent, it's still positive. Or like that, it's a number.
Preseason started.
No, you're -4.
Are you? I was gonna get tickets for it, and then I didn't. Loser. Would you shut your face? You are sorry, sir.
Yeah, I quit.
Yeah, but
No. It's okay. We don't have to worry.
Did you get an excuse? Not
Yes. There is. Just trying to just share.
So, my 2x
Yeah.
You have the normal.
So what I do is I auto put out the text and then I just do this. So wait. Okay, I messed this entire thing up.
I'm going to guess that you messed up the derivatives. So f prime of x, you should have gotten negative 10x over x squared minus 4 quantity squared. The second derivative. Have you guys gotten to your second derivative yet? Okay, I will give you guys another minute or two.
Okay, it's been a second. I'm checking you this.
All right, do we have it?
I'm so proud of that right now. That's right there.
Maybe.
Why no, I don't know.
Okay, that's been 30 seconds. So you should have got 10 times 3x squared plus 4 all over x squared minus 4 to what power? Cubed.
Oh, yeah, that is what. Yeah, I did pull out the
I did get that.
but yeah.
But if I on down and I forgot my number, because that's the row. So I have to be.
No, 30 plus 40 over, yeah.
Because there would have been an x squared minus 4 in the numerator, right? That simplifies. That's why it's not to the 4th power in the denominator, because there's one that simplifies. Does that make sense? Okay. Now, what do? We set it equal to 0. Okay, specifically the numerator, correct? So when you set 0 equals to 10 times 3x squared plus 4, is there anything that makes that true? No, right? If you solve this, you're going to get imaginary solutions, correct? There's nothing squared times positive 3 plus 4 is ever going to get you to 0. Like there's no way for that to happen. Does that make sense? So the idea here then, right, is, well, there's no points where it's 0, but what's our issue in the denominator? We have points where it is not continuous, right? So x equals positive 2 and negative 2, right? Yeah, because 2 squared is 4 minus 4 is 0. And negative 2 quantity squared is 4 minus 4. Yeah, so these are the points that give us issues, right? These are the points, right, for our interval. Does that make sense? So f is not continuous at x equals plus or minus 2. Do we agree? So now what do? We create our intervals, right? What are our intervals going to be? Negative infinity to negative 2. Negative 2 to 2. 2 to positive infinity. Okay, I'm going to give you guys another minute or two to finish your table. You guys don't need calculators. I'm being like, because what are we going to do on the AP test if this is on a non-calculator section? Okay, what are your guys? You make your lives so hard. Okay, what point are you guys plugging in? Negative 3, 0, positive 3. Okay, let's just talk about this. Look. Okay. My numerator is always going to be what kind of number? Positive. It's always positive because it's something squared. No matter what I plug in, this will be positive. The denominator is the part that might give us issues, correct? Yes. Okay, negative 3 squared is what? Positive. It's positive and bigger than 4. Yeah. So this here is going to be positive. What is a positive cubed? Positive. I have a positive over positive, which is? Positive. Okay, if I plug in 0, right? Here, I'm going to have a negative number cubed, which is what kind of number? Negative. So I will have a positive over a negative, which is? Negative. Does that make sense? When I'm saying we don't need to actually know what the value is, I can figure out the signs and figure out, is it positive or is it negative? Does that make sense? Yes. Because there's a very real possibility that you might have something like this on the non-calculator portion. And if you don't have a calculator, right, you're not able to go plug these things in. And you shouldn't be wasting your time, right? Imagine if this is, imagine when these are more complex or these intervals are larger and the numbers you're plugging in, right? All we have to do is try to use number sense to get where we want to be. Does that make sense? Our number sense struggles, I know. We've had this conversation since I had you guys 2 years ago, right? I'm not mad at you guys about it. It's not your fault. It's the hands that we are dealt with because that's the state of education. Okay. F double prime of negative 3, what did we say? F double prime of 0. F double prime of positive 3. Okay, so we are concave up, concave down, concave up. Does that make sense? Are we all okay with this? Okay, now let's talk about the definition of a point of inflection. You guys talked about points of inflection last year, correct? Yes. Super cool. That's why my hand sanitizer got taken away.
Is that why everyone's?
Okay, so here's the idea. A point of inflection. Okay, a point of inflection, right, is where a graph changes concavity. Right? Do you guys remember this from last year? Yes. Right, so if I have something, right, so if I have this is concave down. This is concave up. Right here is our point of inflection. Do we agree with that? Does that kind of make sense? Okay. Don't need to go super deep into the definition of concavity or inflection points. We're okay? Okay. So, it's a small little theorem, right? So our next theorem says if the point C, f of C, is a point of inflection. Okay? On the graph of f, then, Mr. Disbang, what can we say? What does f double prime of c equal? 0. Or f double prime of c does not exist. Think about the last example, right? We had concavity, right? Because we had asymptotes, right? That's what was happening.
Yeah, everybody needs to let know. He's watching our face.
Just making sure you didn't take. Was your mom mad that you gave a bunch of the wallets away?
I forgot to, I forgot they were in my bag.
Some kids, man. Okay. So to be clear, okay, it is possible, listen guys, it is possible that the second derivative can be 0 and it's not a point of inflection. Okay? So it is only true this direction. If it's a point of inflection, then we know the second derivative is equal to 0 or it does not exist. Just because the second derivative is 0 does not necessarily mean there is a point of inflection. Does that make sense?
Yes.
Okay. All right, let's go and find some points of inflection. Very similar to process to what we just did. So we have f of x equals x to the 4th minus 4x cubed. So what I want you guys to do is determine your concavity and find your points of inflection. Go team, go.
Jordan.
Do not. You said X to the third, and we just.
What do you say? Take the paper to your mouth.
Jordan.
What are you guys on now? Three variable functions.
What did you guys get?
Yeah. Let's go, baby. 3D calculus.
Yeah, X equals 2, bro.
It's actually, I think it's easier.
Oh,
Like legitimately, that stuff is easier than.
Mine's 4 and X minus 2. So is it X equals 0 X equals 0
X equals 0.
Is Jordan here today?
Yeah. It's not like.
It's not like super injured, it's
No,
just.
it's just like both.
No, because you have to divide by 12. Is it just 2? It's 0 divided by 12. Yes. And then. Yeah.
Jordan, if it's on
If you divide by 2, 0 divided by 12.
oh, yeah, it is 2. You guys get 0 and 9. No, I did the math right. It's 7 out.
And then you find.
What you do? What are you doing?
Oh, so
Yes,
where's
I
it?
got X.
Actually, one of the X's.
I got it. How do you know?
Wait, what are we doing? Never mind. You can divide it by 12. Zero is just over.
You backtrack 12. When he gives us you said 4.
You like what? What'd you say? You said something. I'm going to assume that it's the worst thing. Whatever you said then.
then that affects mine here.
I just looked at it and like,
Wait.
when did you
So, I think for the back. So find the points of inflection. Yeah. Yeah.
We're solving for something.
Okay, so this is what your table should look like. So where are our points of inflection? X equals 0, X equals 2. How do we know? Because it changes concavity. Does that make sense? So if we went from concave up to concave up, that would not be a point of inflection. Does that make sense? We're all good. No questions. Okay. We're all good. All right. Big theorem. This is the second derivative test. So to be clear, right? Second derivative tells us about concavity. Are we good? We're good there. Okay, the second derivative test is going to tell us about extrema. Does that make sense? Okay, so here's the idea, right? Let f be a function such that f prime of c equals 0. What does that mean c is? C is a critical value.
Yeah.
Right? It's the values that make your second or your first derivative 0. Does that make sense? C is a critical value, okay? And the second derivative of f exists on the open interval containing C. Okay, we're going to have two cases and then kind of an add-on piece to it. Okay, if f double prime of c is greater than 0. Think about that. My second derivative at this point is greater than 0. What does that tell us about the concavity? So what kind of extrema would we have? A relative minimum, right? At c f of c. So think about it. Second derivative is positive, so it's concave up, which means the extrema that we have is is a relative minimum. Does that make sense? Okay. What do you guys think the second bullet point is going to be? If f double prime of c is less than 0, then f has what? A relative maximum. Because if the if the second derivative is negative, our concavity is down, which means that we would have a relative minimum at that point. Nope. Does that make sense? Okay. There's a very big caveat here, okay? If f double prime of c equals 0, okay, then the test fails. Okay? So what that means, right, is f can have either a relative minimum or a relative maximum there. We don't know which. Okay? What do you think that we're going to do? Use the first derivative test then, which also tells us about extrema, right? So if the test fails, right, f can have a relative min, a relative max, or neither. Okay? Whatever happens though, we'll use the first derivative test.
Why would we always use the first derivative?
I don't know. Why don't you think about why we would not always use the first derivative test? Okay. I guess we'll figure it out then.
That's so condescending.
It wasn't meant to be condescending.
I know when you said it, like, oh, yeah, I didn't think about that, huh?
No, I think it's a good value, like it's a valuable question. Because I know that he's not the only one that's like, well, if I'm going to have to potentially use it anyways, why wouldn't I just always use it? Who knows? Bo knows. That's a reference none of you guys get.
Oh, no.
All right. Are we still writing or are we okay?
Yeah.
We have one more example and then we're done. And then you guys get time to work on your homework. Except for G. G has to stand in the corner of shame. Yeah, maybe. I don't know.
That corner? Or that corner?
I don't know.
I think it should be that one. It's dark with blue.
And your boss, I guess.
Well, no, because that one,
No, because she might accidentally press the emergency call button and we don't need that.
that one, like, she should just go that way.
Why are you guys sending me?
We need a chair to face the wall.
No, in the corner of shame, you don't get to sit. You need to be uncomfortable.
That's cruel.
Did you guys ever have that punishment when you were a kid where you guys got sent to the corner?
Yeah.
So no, I for sure did, and then my grandma forgot about me, and so I stood there for like 3.5 hours. And then finally I was like, hey, can I come out? And then she felt really bad and made me a cake. That was the lesson. I have no idea what I got in trouble for, except for the fact that she forgot about me in the corner.
You got cake, that's all that's...
I got cake, man. That's all that mattered. Okay. I want you guys to find the relative extrema of f of x equals negative 3x to the fifth plus 5x cubed.
You're seriously gonna ask that?
Okay, so things that we need to do. Differentiate. Set the first derivative equal to 0 to get our critical values. Then we need to differentiate to get our second derivative. Do we agree? And then we just plug in those values. I'm not asking about concavity in this case. Does that make sense? So what is our first derivative? Dude, you guys pump me up. Thank you. That is... It's like you guys rehearsed that and I'm mildly terrified. All right, we set this equal to 0. You get 0 equals negative 15x squared times x squared minus 1. So we get x equals 0, 1, negative 1. Make sure... Obviously, it's going to be like tools of the trade, right? Because I pulled the negative out, so that way I got a difference of squares. Other way will still end up working. Okay, so those are our critical values. Do we agree? Okay, Now, what we need to do, okay, is get the second derivative. Our second derivative is what? Negative 60x cubed plus 30x squared. Okay? Oh, yep, thank you. Okay. Now remember, I don't actually care about the values, right? What we care about is what? Is the sign, right? So think about this. We have our critical values. We have x equals -1, x equals 0, x equals +1, right? F double prime of -1 is going to be what kind of number? It's going to be positive. Guys, -1 cubed is negative times -60. Positive 60 minus 30. It's positive. F double prime of 0. That equals 0. So that tells us what? We'd have to use the first derivative test.
On the whole thing or just that one?
Just this point. Okay? F double prime of 1 is what? Negative. Okay, so to be clear, because it's positive, we have a relative what? Minimum, because it is concave up. Here, we are going to have a relative maximum. Why? Okay. Now, the first derivative test, right, tells us what? If it changes from increasing to decreasing, it's a maximum. If it's decreasing to increasing, it's a minimum. Use the first derivative test. And you will find that your function is increasing to increasing. Which means what? It's neither. So, remember guys, it's where you create the interval. You'd go -infinity to 0, 0 to positive infinity. You'd figure out the sign of your first derivative. If the sign's positive, your function's increasing, right? If it's negative, it's decreasing, right? But I'm telling you guys, so you'd plug in -1 to the first derivative and +1 to the first derivative. Or different numbers, right? Something in those intervals. But what you would find is your function is increasing to increasing. Because the sketch of what this function looks like okay. Here is our relative minimum. Here is our relative maximum. Here's where the point is neither. Don't worry, we're going to really solidify our curve sketching tomorrow. We okay? All right, you guys have like 30 minutes. Grab a Chromebook, grab a book, work on your homework.